Whenever we factor, we first look for the greatest common factor. In this case, there is no greatest common factor, it's just 1. So then we count the number of terms. This has 3 terms, so I'm going to use AC method. So AC method says you say what A, B, and C are. In this case, A is 7, B is 9, and C is 2. Then I write down all the factor pairs for A times C. So A times C is 14. So factor pairs are 2 numbers that multiply together to be this product. So 1 and 14, 2 and 7, 3, no, 4, no, 5, no, 6, no, and then I'm back to 7. So I know I have them all. But I also have to remember that it could also be not only 1 times 14, but -1 times -14, and -2 times -7. So any of those factor pairs. So I want to find the factor pair that adds to B, and in our case, B is 9. So which of these pairs adds to 9? Well, it's going to be 2 and 7. So when you're doing factor with the AC method, what you're doing basically is you're just rewriting 9G using these 2 numbers. So 9G is the same as 2G plus 7G. And I'm getting that 2 and the 7 from the factor pairs that I found that multiply to 14 and add to 9. So basically, I've taken this 3-term problem, and now I've made it into a 4-term problem. It's exactly the same expression, though. And then I can use factor by grouping. So I do the first 2 terms, and then I do the second 2 terms. Well, there is no greatest common factor for the third, and fourth terms. So I just have a greatest common factor of 1. Then I reunite them, and I say G plus 1 times 7G plus 2. And the way I looked at that, I found the greatest common factor was 7G plus 2. I write it, and then I write whatever's left over as my second binomial. Or, like I showed earlier, you can put the 4 terms in a box. And then look for the greatest common factor of the first row, which would be 7G, and the second row, which would be 2. And then I do the columns. My first column, the greatest common factor is G. And in my second column, the greatest common factor is 1. Whatever the term is touching is the sign. So G is touching 7G squared, which is positive. 1 is touching 7G, which is positive. 7G is touching 7G squared, positive. And 2 is touching 2G, positive. So it's G plus 1 times 7G plus 2. Same answer, just a different way to get there. And once again, you can check your answer by multiplying what you get to make sure you get the original problem. Do the second one. So A is 6, B is 5, and C is -6. Okay? So I look what AC is. AC would be 6 times -6, which is -36. So I want factor pairs for -36. And I just go right down in line. I start with 1 and -36. And then I go to 2. Don't go out of order and you'll never miss any. And -18. And 3 and -12. 4 and -9. 5, if I put it in my calculator as decimal, if I divided 36 by divided by 5. And then 6, I can definitely do. You can see now I'm to the middle because I know that if I looked if I go the other direction, I'm just repeating what I've already done. Now, to make a -36, I can do 1 and -36, or I might do -1 and 36. I have to consider both. Now, I want to find which pair adds to B. And in our case, B is 5. Well, I can see that -4 plus 9 is 5. So I'm going to regroup 5, and instead of writing 5, I'm going to write -4F plus 9F. That's equal to 5F. So I'm just taking my middle term and making it into 2 pieces, 2 terms instead of 1. And now I can use factor by grouping, which says find the greatest common factor of the first two terms and the greatest common factor of the third and fourth terms. And then reunite them. And then the greatest common factor is 3f minus 2. And my second binomial is whatever's left over. So 2f plus 3. Or put it in a box and use those pairs, so negative 4f and 9f. I look for the greatest common factor of my top row, which is 3f. My greatest common factor of my second row, which is 2. My greatest common factor of my first column, which is 2f. And my greatest common factor of my second column, which is 3. Whatever it's touching is a sign. So this 3 is next to 9f, which is positive. But this 2 is next to a negative 4f, so it's going to be negative. So you can see I get 2f plus 3 times 3f minus 2, which is the same answer. Either way, you can choose whichever you like. And you can also check this by multiplying. Next problem says to factor completely using the difference of squares pattern. It's even giving you the clue, so make sure you don't miss that. So difference of squares says that a squared minus b squared is equal to a plus b times a minus b. You need to memorize this. So when you have two terms, you're going to always first find the greatest common factor and then count the number of terms. If you have two terms, you're going to try difference of squares. Okay? The only ones we've learned in here are difference of squares and difference of cubes. But you can clearly see this is a 2, so it's difference of squares. And you're going to rewrite the first term and the second term. And just rewrite them as if they're squares. So what squared would give me 25y squared? So 5y times 5y gives me 25y squared. If you get a number that you don't know, you could take the square root of it to find out what squared would give you that number. Okay? And then the square root of 49 is 7. So we know that a is this base and b is this base. So I'm going to say 5y plus 7 and 5y minus 7. Notice I do not use the square. Notice in here, this is the big mistake people made. They want to put like an exponent here. There is no exponent. It is strictly the base, a and b. So we want to just use the base and not take the exponent with it. And that is my answer. So we're going to start with part B here, the vertex. And when we have a quadratic in standard form, we know that the vertex is HK. And to find H, we say negative B over 2A. So in our problem, we have A is equal to negative 4, B is equal to negative 28, and C is equal to 24. Okay, so when I'm putting it into my equation here, I myself draw parentheses around the letters and then I put them in. So negative 28 and A is negative 4. So it's going to be 28 over negative 8, which will be 7 over negative 2. Now to find K, you're just going to input H into your original equation. So in other words, wherever there's an X, I'm going to replace it with negative 7/2. And I can use my calculator to help me do this. And I will get 73. So my vertex will be negative 7/2, comma 73. Now, start with B because A then will be very easy. My axis of symmetry is always X is equal to H, where my vertex is HK. So in other words, whatever my X coordinate is for my vertex, I'll say X equals negative 7/2. And this will always be my equation of the axis of symmetry. So I would always start with this one first And that way you'll get the h, and then you'll just say x is equal to whatever that h is. Now, if you wanted to check this in the calculator, you could. So get those calculators out, and we'll show you how to do it. Okay, so I went over to y equals, and I clicked on that, and I'm going to enter in my equation. Now, notice when I use a negative, I use the bottom row. And when I graph this, I can see, oh, I can't see, well, I can see part of it. It's a parabola. I could zoom out if I wanted to. So if I wanted to see more, I could say zoom and then out 3 and then hit enter. And you can see more of the parabola, right? So our parabola looks like this, which makes sense because of it's got a negative a, so it's going down. And I can see my vertex is going to be up on the top here. So if I want my vertex and I want to do it with the calculator, I say second trace, and that's going to be a maximum. When my parabola is pointing down, this is going to be a max, right? If it had been pointing up, you see this is the minimum point, right? We don't have that though. We have a maximum. So I'm going to choose 4. It's important to choose the right one. Now it says left bound. In other words, you want to choose any point to the left of the vertex. So right now my little guy, my little X spider is over here, right? So look at my calculator, you can see it. It's not left, it's right of the vertex. So I use my left and my right arrow keys, oops, until anywhere to the left of my vertex. So now my little guy, the little blinky cursor, he's no longer over here. Instead, he's over here. So that is left of my vertex. So I hit enter. Now it says right bound. So I want to point anywhere to the right of the vertex. So once again, I'll use my right arrow. I'm only going to use my left or my right. And there he is. So now my little spider, my little cursor is to the right of the vertex. So I'll hit enter. And it says guess. We never guess. We just hit enter. And it tells me my vertex is negative 3.4999973. Well, you have to remember the calculator is doing it graphically, so you're going to have a teeny weeny bit of round off. So if you get a number like that, just be aware of that. That's really negative 3.573, which is the same exact answer that we got when we did it manually. So just be aware of round off. If you ever get on the calculator like 0.0000001, that's just a little bit of round off, that's just 0. And if you get something like 4.9999999, that's really 5. It's a little bit of round off from doing it graphically on the calculator. The next problem, just make sure that you understand what function notation looks like. So for part A, remember, whatever is in the parentheses is my x. That's my input. So we're going to replace, everywhere there's an x, I'm going to say 7. So 6 times 7 plus 4. So remember, this is the function at 7. It does not mean f times 7. This is a fancy way to say y. So that's going to be 42 plus 4 is 46. Okay, now let's look at part C. So part C says my input is k. So wherever there is a x, I'm going to replace it with k. And so my answer will be just 6k plus 4. So don't make it harder than it is. That's all we're looking for here.